Good morning. Okay, guys. Now, let's just resume where we finished yesterday. Let's see. So we're going to be on page 430, question 43.
Mike.
Yes, my dear.
So, just to clarify, which chapters are going to be on the first quiz?
1 to 5.
1 to 5. Okay, thank you.
We'll be done far before the quiz date. Okay, so what we saw is, okay, is a force is applied on a surface, or to a surface. If the force is tripled and the area over which the force is applied is also tripled, what is the new pressure? So we knew that pressure equals to force over area. Clear? Okay. Now here, yes, okay, guys, although yes, okay, there aren't numbers in the questions. And it's merely, yes, okay, just a question about, yes, okay, the relationships. But just to get, okay, yes, what the question says, let's just put some numbers. So we can say, it's okay, initially, force, we can just pick up any number. You can say, yes, okay, 4 newtons. Clear? Okay. And okay, yes, it's applied onto a area. So we can say, okay, initial area is, let's just say, 2 centimeters squares. Okay. Now what they say is that, okay, yes, the force is tripled. And so is the area tripled. But let's just calculate, yes, okay, our initial pressure. Or we can say, okay, the initial pressure is going to be 4 divided by 2. So we can mean it as, okay, that's going to be 2 newtons per centimeter square. Now, when they say that, okay, yes, the force is tripled, that may mean that, okay, yes, our final force is going to be as, okay, those 4 newtons increased 3 times. So that becomes a final force is going to be 12 newtons. Clear? Okay. Likewise, when they say that, okay, yes, the area is also tripled. Okay, so we can mainly say, okay, that now the final area that is going to be the initial area, which was 2, is also tripled. So now do we have a area of 6 centimeters per, or 6 square centimeters. And now it just comes down to, yes, okay, calculate the final pressure. So that's going to be, yes, okay, your final force, which is 12, divided by the final force, which is 6, which becomes 2 newtons per centimeter square. Did that make sense?
Yes.
Right, okay, okay. So what they did here was that, okay, yes, they changed the pressure. That's why they changed both the force and area equally. Okay. Had it just been the force that has been changed, then your pressure would have increased 3 times. Clear? Had it only been the area that had increased 3 times, okay, or you can say, okay, the area had only been the area that had increased, then, okay, yes, the force would have reduced to 1/3. No, sorry, the pressure would have reduced to 1/3. Clear? Did that make sense? But since that's okay, they both equally change. That's okay. That's why it's okay. The final pressure and the initial pressure is going to be equal. That's okay area. Clear? Did you guys get that?
Yes.
Okay. Good. Let's just look at the next question. So, okay, as a longitudinal wave propagates from east to west. Now, okay, let's just make a compass here first. So we are north, south, east, and west. Okay. So what do we say is, okay, as longitudinal wave, yes, okay, propagates at a speed of 2 miles per hour from east to west. So I mean, yes, okay, a wave that travels at from east to west at 2 miles per hour. Now, what is the direction of the motion of the particles? Okay, and mainly because we said, okay, this wave is, okay, was longitudinal. Okay, here is, okay, the speed is mainly as, okay, just irrelevant. You didn't really need the speed. The main thing that we needed was, okay, as the direction. So what we mainly can say now, since it is longitudinal, the particles are going to be moving east to west and west to east. Did that make sense?
Yes.
Okay. Had they said, had the wording being, yes, okay, a transverse wave moves from east to west or west to east, and then they ask, yes, okay, what is going to be the direction of the particle motion? Now, since they say, yes, okay, transverse wave, yes, okay, the particle motion will have been north to south and south to north. Did you guys get that? Okay. And here, yes, okay, the speed, well, okay, yes, it's pretty much okay as information that you really can't use. Okay, so although yes, okay, you saw a number, well, okay, yes, there was no calculations involved. As long as you know, yes, okay, the relationship between particle motion in longitudinal waves, at least for this question, yes, okay, you'll be good. Did you guys get that?
Yeah.
Okay. Let's just clear this up. Now we can say question. Okay. 44. That's going to require a jump. Now, the direction of motion of a particle in a wave is perpendicular to the direction of the propagation of the wave. What type of wave is this? Now, guys, please keep in mind that, okay, as the word perpendicular is going to be as okay, where we later on we call as okay at a 90-degree angle, which also is okay, will be known as a right angle. Now, what they mainly say is that let's just take any direction of the particle motion. Let's say that the particle motion is in this direction here. And the direction of the wave is perpendicular or a 90-degree angle. Now, what kind of wave do we have here? It's going to be a transverse wave. Did that make sense? So the main is okay, just cheated you with the word perpendicular. Yep.
Yep.
Good. Okay. Again, 46. Now, a particle within a transverse wave is traveling vertical. So they already said, okay, yes, this is going to be okay, a transverse wave. But what they say is that, okay, as the particles motion is vertical. Clear? Okay. Now, what are they asking? What is the direction of the wave's propagation? Now, we already know that, okay, yes, in a transverse wave, particle motion and the motion of the propagation of traveling of the wave is going to be at 90-degree angles, or transverse, or perpendicular, or across one another. So that's okay. The direction in which your wave is going to be moving here is going to be horizontal. Yeah, okay. Did that make sense? Had it been a longitudinal wave, that it says, okay, that your particle is moving vertical, well, okay, then the wave itself, then the wave would also have been moving vertical. But that could have been, yes, okay, it could have been a longitudinal wave. Did you guys get that?
Yep.
Okay, so you can see, yes, okay, mainly, yes, okay, just your general concepts. Question number 47. Now, what wave exists? Okay, wave that exists at the same time, or at the same location and time, will combine. What is this called? Now they say waves. That will mean that it's going to be, yes, okay, more than one. Okay, at same time and location. Now, what's going to happen? That is going to lead to, yes, okay, what we call interference. Okay. Now just be careful between option A and D, or A and C. Clear? Okay. To begin with, yes, okay, they may look alike. Okay. And what they, yes, okay, know is okay for some instance, okay, many people just tend to read, yes, okay, the first 2 or 3 letters and the last letters and just make up the middle part. Okay. So yes, okay, it's not inference. What rare fraction is? What was a rare fraction? Over a rare fraction. Yes,
The
guys.
particles are spread apart.
When the particles are split apart. Exactly. Okay. Clear. Okay. Question number 8. 48, sorry. Two waves arrive at the same location and interfere. So we have 2 waves. Okay, now they reach the same location and okay, yes, that's it. Okay, interfere. Okay, now the resultant wave is smaller than either of the 2 original waves. What is this called? Now, when you say it's okay that the final wave or resultant wave is lesser than either A or B, that is because we had, maybe because it's okay that A was subtracted from B or B subtracted from A, whichever. And that was going to be, it's okay, what we call destructive interference. That had it been opposite, that they would say, it's okay, that the final wave is greater than either A or B, then that would mean it meant that we have had constructive. Why? Because okay, A has to be added onto B, or B has to be added onto A. to make it either greater than A or greater than B. Clear? Did you guys get that?
Yeah.
Yeah.
Good. The last question of, okay, as this chapter here. Question 49. Now a pair of waves are in phase. So what do we have? The waves are in phase. Okay. It's a pair, so it's two waves. Okay, good. What occurs when these waves interfere? Now that's easy to remember, as I said. Okay, that's going to be constructive interference. Yeah, okay. Why would you be able to say that, okay, it's constructive interference? Because it tells you that the waves are in phase. Had it said out phase, then you had destructive interference. Clear? Okay. Had they just said two waves interfere, what's going to happen? You will not be able to say whether that was constructive or destructive interference. The only thing you could say was, okay, they will interfere. Right, okay. So you can see, yes, okay, well, okay, at least for now, not so difficult. As long as, okay, as you have your concepts intact, you should be good. So yes, okay, now that was all that I could offer for chapter number 2. Any questions? Now, one part of chapter 2 is just, okay, still to be discussed. But that will be, yes, okay, chapter 3. Right, okay. Because that's okay, what they talked about was, we had that on page number 12, acoustic parameters. So chapter number 3 is nothing more, but mainly, yes, okay, just a detailed account about your acoustic parameters. What were they? What were your acoustic parameters? Period, frequency, wavelength. The 3 biggest parameters, which were amplitude and power, intensity, and amplitude. And the last but not the least is going to be the propagation speed. So that's pretty much okay. That's mainly okay what we'll be start talking about today. Yeah. And we can say as okay, the real signs of okay, yes, relationship knowledge is going to yes, okay, kickstart. Okay. So now guys, when you look about yes, okay, when you look through the book for each of yes, okay, your parameters. The first thing that you may see, yes, okay, is a box where 5 things are being mentioned. First of all, they will say, okay, how do you define this parameter here? What is the definition of this parameter? Or what is this parameter here all about? Is that clear? Okay, Caitlin, we're just starting with chapter 3.
Perfect timing. Thank you.
Okay. So I just did the remaining questions in the exam review with guys. Okay, so one is going to be as, okay, how do you define this parameter? What's the definition of this parameter? Second thing is as, okay, what would be the unit for this parameter here? Clear? Another thing that you will see is going to be as, okay, a typical value. Okay, now please guys, as, okay, these typical values here, the typical values that are given in your book are only going to be as, okay, relevant to as, okay, ultrasound waves. Clear? Okay. Or we can say, okay, the typical values of, okay, a certain parameters of sounds that are being used in ultrasound equipments. Did that make sense? Okay. Those typical values may be different for other things. But for ultrasound, yes, okay, these will be our typical values. Okay. Which is mainly as, okay, just going to be a number with a unit. Now, guys, some of these typical values here, you just have to remember. Okay, so which typical values you need to know, which typical value you can say, okay, Hakuna Matata, that one, I will let you know. Clear? Okay, but there are going to be, yes, okay, some typical values which you will have to know, just like, okay, yes, your birthday, your social security, whatsoever. Clear? Okay, the main two, yes, okay, important things here is what determines your parameter. Okay, what is going to be determining your parameter? And if you know that, the next question is, or the next point is this a parameter that can be adjusted? Clear? Okay. Now, if that box says yes, if that box says yes, that may mean that, okay, yes, this is something that you as a sonographer may be able to change on your system. Which means to me there will be a knob, there will be a button, there may be as, okay, a function on your system on the touchscreen and so on and so and so, where you can go in and tick, 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 change your options. So you are able to adjust it. Is that clear? Okay. But still, yes, okay, you still have to keep it within the range of the typical value. Clear? Okay. If it says no, then okay, you will not be able to go in and change the setting. Or there will not be as, okay, a knob or a button that you can turn right or left or twist right or left that will be enable you to change this. Clear? Did that make sense? And after that, yes, okay, there's going to be a bigger or shorter discussion of relations. How is this factor here, so okay, this parameter here is, okay, related to any of the other parameters? And if so, what kind of relationship is it that they have? Did that make sense? Okay, now what I said back then when we talked about relationships was that, okay, yes, if two factors or two parameters were related, if you change one parameter, the other parameter will also change. Now, the way that they change is going to be as, okay, dependent upon the relationship between those parameters. What kind of relationship did they have? Were they directly related? Were they inversely related? Clear? Okay. But if they are not related, that is okay, you can change one parameter, well, okay, it's not going to affect the other parameter. Did that make sense? So pretty much that's okay. This is going to be as okay the main essence of this chapter here. There are going to be as okay a couple of small formulas or equations, and again, mostly as okay they are determined by the relationships. Okay. Any questions before I start? So that's okay. A list of 7 parameters: period, frequency, wavelength, amplitude, power, intensity, and the propagation speed. Now again, that's okay. Before we get started with the real details, because that's okay. What I mean, yes, okay. It talks about in the intro. That's okay. Oops, no, don't do that to me now. Okay, that's better. Okay. When one was source. Clear? Okay. And for our case here, it's okay. The source main is going to be the transducer. Now you may see that, okay, as for 3 of our parameters, what they will talk or and they will refer to the source is going to be as okay, the system. Yeah, okay. And the system that's going to be as okay, that bigger or smaller piece of equipment, whereas okay, as the transducer is mainly as okay, just that joystick. Okay. So guys, that's okay for 3 of our parameters. That's okay. What we mean by the source is going to be the system. It will mention that, okay, I'm talking about the system. Next is what we call medium. And in our case here, it's okay. The medium, that was going to be the tissues. Clear? Okay. And when we get later on, yes, okay, probably yes, okay, the last topic of the chapter, we'll talk about, yes, okay, that we have 3 forms of tissues. We have solids, we have tissues which are liquid, and we have tissues which are gases. Okay. So some of your parameters are going to be as okay, wholly and solely as okay, determined by the transducer. Some parameters are going to be as okay, still be determined by the source of sound, which is going to be as okay, well, in that case will be the system. There's going to be one parameter which is only going to be determined by the tissues. And that's going to be as okay, one parameter which is going to be determined by both the transducer and the tissues. Yep. Okay, guys. Now, our first parameter. Now, before that, any questions about, yes, okay, what we mean by source versus medium?
Nope.
So you guys are good upon that.
Yeah.
Okay. So for now, yes, okay. When we say source, yes, okay. Unless and until, yes, okay, specified that, okay, as source for mean system, yes, okay. Just think of it being, yes, okay, the transducer. Clear? Okay. Now, guys, in the other chapters, we will actually, yes, okay, get more clear upon, yes, okay. How is it that, okay, yes, if you said source, yes, okay, how is it that the transducer actually, yes, okay, is able to, yes, okay, determine this, these parameters here, or at least some of them. Okay, guys, let's clear this fellow out. So our first parameter is period. Okay, now please, guys, these are all, yes, okay, parameters of your sound waves. Okay, so what a period is going to be, period and only period. No prefixes, no suffixes, but just a plain period. That's going to be the time that it takes a cycle of sound complete. Yeah, okay. Now this cycle here is okay. May also is okay. You can also call it a wave. And guys, theoretically, yes, okay. I mean, it says okay, a wave or a cycle is going to be like this. This is one complete cycle where you can mainly say, okay, well, okay, yes, we have a peak, we have a trough. Yeah, okay. But pretty much, okay, yes, if we measure, yes, okay, the time that it takes from the start of the wave to the end of the wave, and take that measurement in terms of time, that is going to be referred to as a period. Did you guys get that?
Yes.
Okay. So we can just put it this way here and say, yes, okay. Let's just assume that each word that I utter or speak, just for an example, clear, okay, is one cycle. Okay. And the time that I take to speak each single word is going to be, as okay, the period. Did that make sense? Okay. So not the period of, okay, as the whole paragraph. Okay. But here's, okay, just the period of each single word that I spoke. Okay. Now, please don't come back to me and say, Mike, where in the hell did you got that idea that each word is made out of one cycle? I never said that. They're just going to give an example. Clear? Okay. Okay. So if I speak, yes, okay, if I take 1 second to speak each word, that time could be, yes, okay, a period. Did you guys get that? Okay. Now, guys, since, well, okay, it is something that is going to, yes, okay, be measured in terms of time. There should be no doubt about it that, okay, yes, the unit, okay, that we measure this here in terms of time, and that will be called the period. So yes, okay. The unit of period is going to be, yes, okay, the unit of time. Okay. Okay. So any unit of time can be used to express the period. Okay, you can say second, minutes, hours, days, weeks, months, so on. So, okay, as long as, okay, it is a standard unit of time, yes, okay, that can be used to express the period. Did you guys get that?
Yes.
Good. Now, guys, now you're getting to, yes, okay, an interesting fellow. Because that's going to be, yes, okay, the typical value. And okay, guys, one reason that we call ultrasound is mainly because it's going to be, yes, okay, cycles that take, it's okay, a very, 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 very small time to complete. Okay, so the typical value mainly, yes, okay, is going to, yes, okay, be from a range. This is going to be 0.06 microseconds to 0.5 microseconds. So what we mainly can say is that, okay, yes, this here is the lowest of the typical value of your ultrasounds. This one here is going to be, yes, okay, the highest. Now, guys, let us first look at, okay, yes, the unit microsecond. The unit microsecond actually is going to be, that's okay, 1 over a million of a second. Did you guys get that? So a microsecond is going to be that, okay, as if you took a second and divided that into a million equal parts, each of those was going to be, as okay, 1 microsecond. Is that clear? Okay. Now, if you just look at, so if you just look at this fellow here, the maximum, even that is, yes, okay, now 0.5 microsecond actually means, it's okay, half of a microsecond, right? Okay. Half of a microsecond. Now this value here is okay. These values, like we can stick this maximum first. There's 0.5 here. Can still be written like this. Now your micro can be written as 10 raised to the power minus 6. And okay, yes, your seconds. Yeah. Okay. But this 10 raised to the power minus 6 here means that this number here is going to be as okay a 6 decimal number. So that's why it's okay this 0.5 microsecond could be written like this, but it could also be written like, okay, yes, we can have it, okay, as the 0 point. But then we go, yes, okay, with 6 zeros. Okay. And then 5. Seconds. Did you guys get that?
Yeah.
Yep. Whereas if we go on to the next side, or we can use, okay, write that, and we say, okay, we don't want to write this here in a fraction. We want to write this here as a whole. But okay, yes, it becomes 5. I can just say it's okay, times. It's okay. Your 10 plus, that's okay, we add the minus 6. But since it's okay, we made it okay, convert that's okay, the digital number into a whole number. Okay, there's going to be it's okay. Which will be plus minus 1. Every actually that's okay ends up with minus 7. That's okay. Of a second. Okay. So all these here is okay meant the same. So likewise, guys, okay, when we find that's okay, go on to the minimum value. Okay, there's 0.5 or 0.06 microseconds could also be written as, well, let me just, okay, there's 0.6. Your micro is still, yes, okay, 10 raised to the power minus 6, and okay, yes, your seconds is seconds. Yeah, okay. But that could again, yes, okay, be written as 0 point. And we just going to just okay, go with plain seconds. So it's actually going to be as okay, those 6 seconds, or 6 zeros first. And then 0.6. And then seconds. Or likewise, okay, if you want to write it as a whole number, you can say as okay, the 6 becomes 6. You had your 10 raised to the power minus 6, which was okay as the micro. But here's okay, you move it 2 digital places, so it's okay, that minus 6 is going to be added with minus 2. So you actually, it's okay, end up with minus 8 seconds. So 6 raised to the power minus 8 seconds. Did you guys get that?
Why did you add -2? Where does the -2
Because we
come
moved the
from?
decimal over two numbers, right? Okay. To make this a whole number. 0.06 is a fraction, right? Yes, my dear. 0.06 is a fraction, right?
Yes.
Okay. Now, if you just talk about it, yes, okay, in our currency terms. If I give you, yes, okay, 0.06 of a dollar, what would that be equal to? 0.06 of a dollar is equal to what?
6 cents.
Huh?
6 cents.
6 cents. Okay, good. Right, okay. So pretty much okay. And that's why it's okay to make it a whole. Because okay, here we still yes, okay, had okay, yes, this was still yes, okay, a fraction of a second. Okay. But even this here is okay, was a fraction of a further fraction of that microsecond. So we want to express it as a whole, yes, okay, that's why we say yes, okay. To get rid of these, yes, okay, we add -2 because this here was okay, it's okay. A two-digit number, a decimal number, right? To make it a whole. Did you get that, my dear? It's just the same as over here. So okay, we added 1 because 0.5 was just one decimal number.
Yep, got it. Thank you.
You sure?
Yes.
Okay. Clear? Okay. Had with friends, let us just, for the hell's sake, that's okay. If we say that, okay, as our typical value, let's say it's okay, that had been 60 microseconds. Let's just say that was the case. And we say that's okay, we want to express the value or the typical value here with a single digit. Okay. Now in that case, that's okay, we'll say, okay, that's going to be 6. Now we had, okay, yes, the minus a 10 raised to the power -6, which made it a million. Or a millionth. But then we're going to say, okay, we just subtract 1. So 60 microseconds was going to be 6. That's okay. Raised to the power 5 seconds. Okay, we got to add here, so plus. Okay, so -6 plus 1 is going to be okay. That's going to be okay. Minus 5. Yep, okay. Now, guys, this typical value where we go like this. Oops, shit, sorry. Remember it. Yep. So, where did you go? 0.06 microseconds to 0.5 microseconds. But just keep in mind, guys, that okay, as this 0.06 here, microseconds can also be written as 0.06. You can convert just okay the micro into 10 raised to the power minus 6. And okay, yes, of course, your seconds is going to be seconds. Clear? Okay. It could also be written as okay as a pure digit, as okay decimal number. As well, okay, it's always is a decimal. You can say, okay, this is 1 sec, and then you take 6 zeros from here, and then 6, and then it's just going to be it's okay second. Or you can write it as a whole number, where okay, yes, you 6, but then it becomes it's okay 10 raised to the power minus 6, and you can say okay plus minus 2, which becomes minus 8 seconds. So that's okay, 600 millionth of a second. The same as okay goes over here. As okay, your 0.5 is 0.5. The micro still is 10 raised to the power minus 6. And okay, yes, the second is the second. Yeah, okay. Or you could write it as a pure decimal number, where you'll say it's okay 0. Well, okay, yes, you have your 6 decimal numbers. Like this, and then you just add 5. Or 0.5, which is going to be, you can say okay, another 0 and a 5. Of course, okay, here is okay, the units is a second. Or you can even go and say, yes, okay, I want to write it as a whole. So it's going to be 5. Now multiply by, okay, yes, you 10 raised to the power minus 6. Now plus. This is okay, the minus 1. Which becomes -7. And of course, that's okay, a second. So the final result is going to be 5. $10 billion or 10 million of a second. But as far as okay, yes, the value of all these are the same. The value of all these are the same. Any questions? Now, guys, the period of the sound is determined by the source only. Or to be more specific, guys, the period is going to be determined by the transducer. Clear? And just look at it in this way. I say, yes, okay. If I take 1 second to speak each word, okay, it's up to you. It's okay. What I want to do, that's going to just okay determine whether I want to speak. I take a second to speak a word, whether I want to take 2 seconds to speak a word or half a second to speak a word. That's going to be up to me. Did that make sense? Okay, so if I go supersonic, yes, okay, like that, okay, yeah, okay. That's just because, okay, I reduce the period to, yes, okay, speak each word. So that's going to be, yes, okay, meaning, yes, okay, the build up in here. It's going to, yes, okay, enable me to do so. Yeah, okay. Now the question is, okay, so of the 2 factors that can determine a sound parameter, period is going to be determined only by the source, which more specifically in this case is, okay, will be your transducer. Clear? How that is determined, that's going to be as okay a later chapter. But for now, just remember this much. Okay, the details of that, just okay, we'll talk about in a later chapter. Now, guys, when it says adjustable, no, your period is not adjustable. Okay, but please mind the words that comes after that. If somebody else, okay, has their books on them, would they mind read it out loud for everybody?
The part where it says adjustable
Yes, my dear.
says no, the sonographer cannot change the period while using a basic ultrasound system with a particular transducer.
Exactly. So here's the word, particular transducer. Clear? Okay. Let's say I'm your transducer now. I speak so fast that the words may just, okay, fly on top of your head. You may go to the administration and say, well, we can't figure out a single word that comes out of Mike's mind because it just go like a jumbo jet. Well, they'll say, okay, well, that's how he speaks. So we really can't change the way he speaks. Right? Okay. They can say, okay, maybe we have a teacher who may speak a little bit slower. So it's okay, well, you guys will see. It's okay that from the next period, it's okay, you will have a new teacher who may be speaking. It's okay, maybe slower. Who knows? Clear? Okay. But it's okay. What that mainly means is that, okay, yeah, there is no button. There is no button. There is no knob on your system that you can twist and turn on that is going to just, okay, change the period of the sound wave. If you need to change the period of the sound wave that has been produced, you will need to change the transducer. You may choose a transducer which has a greater period or lesser period. Is that clear? Yeah, okay. Okay, now before you guys go to the administration, am I speaking too fast? Do you want me to just, okay, go a little slower? I can do that if you like it this way. That's like more depressing to listen to, right? Clear? So what was the period? These guys mind the word period and period only. Later on, we will come across other periods. Later on, we'll come across other periods. But when we say it's okay, period and period only, that's going to be the time that it takes the sound wave to complete one cycle. Clear? Okay. So that time for one cycle is going to be as okay, what you call a period. What unit do we use to measure it? Well, of course, that's okay if it's about the time. It's going to just okay, we use it measuring in units of time. Right, okay, so you can't say that's okay, the period is 22 candies. Okay. Or that's okay, 3 gallons of milk. Or 3 gallons or something like that. No, it's going to use a unit of time. Okay. So yes, okay. Now, if you look, when we look at the typical values, we saw yes, okay, that okay. Yeah, now when we look at the typical value, what we see is that okay, yes, the unit of time that they use is okay, yes, the fraction of a 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 second, and microseconds. Clear? Okay. And anyway, it's okay, a fraction of that microsecond, that's okay, but you can still express it in seconds. That's going to be, it's okay, a hell of zeros, or hell number of zeros after the decimal. Okay, so the easiest way to just, okay, go with numbers like these is to write it in the scientific way, or yes, okay, with the 10 with its exponents. Okay, but it's okay when anything is going to be a fraction, that exponent is always going to be a negative number. Did you guys get that? Yeah, okay. But those fractions or those, yes, okay, that decimal number can also be written as a fraction. Okay. Okay. As far as okay being determined, well, okay, it's going to be the source that will be, or that will determine the your period. Just like, okay, as if it's me who is speaking, it's mainly going to be as okay the way that I am programmed to speak. I will speak at that pace, for instance. Okay. Next to spectus, adjustable, no. Unless and unless, okay, the transducer isn't changed out, yes, okay, the period cannot be the period cannot be changed. Did you guys get that? Good. Any questions? Okay. Now just take a short break for, should we say, 15 minutes? Try to look at as okay your figures for your time or period. And if you still can't figure it out, well, okay, let me know. Okay. And guys, when we come back, please make sure that you guys know what it means to be okay, inversely proportional or inversely related, and what it means to be reciprocal. Okay, guys? Because that's going to get handy. So see you guys at 10:30. Okay, guys. Welcome back. Now, any questions? Please. Nope. Okay, guys, so our next parameter that we will talk about is frequency. Now, the other day we said that, okay, frequency was the number of times a particular event occurs in a particular duration or time span or period. Okay. Whereas, okay, yes, in terms of sound waves, if you talk about if it's going to, yes, okay, when you say the radial frequency, that's going to be the number of cycles If you guys don't like the word cycle, then you can go and say waves of sound per second. Right, okay, that's going to be your frequency. So whatever number of cycles that is completed in 1 second, that's going to be the frequency. Clear? Okay. Why is okay here is okay, or event. Sorry. Or event, what's going to be our event that we are talking about? That'll be as okay a cycle. Clear? Okay. And the number of those cycles per unit of time is going to be your frequency. So if you put it this way and say it's okay, we had a time span of 1 second. In which we mean, yes, okay, I can say it's okay that we got cycles or wave of sound. So we have 1 wave, 2 wave, 3 wave, 4 wave, 5 wave, 6, 7, 8, 9, and 10. So yes, okay, the number of cycles that we had in 1 second here was going to be yes, okay. 10 cycles. Oh, let's put it this way here. So we had 10
Mike.
cycles in a second. Clear? Right? Okay. Or we could say, okay, there was a completion. Okay, there was 10 waves in. They were completed in 1 second.
Mike.
Yes, my dear.
Sorry, are you counting the humps or the troughs? Like, you know what I mean?
No,
Or-
no. Listen, my dear. This is 1 cycle,
Okay, so the up and down.
up and down.
Okay, thank you.
And that's why I said, okay, here. That's why I marked it here. And I go and up and a down. Now I'll mark the second, like that. Clear? Okay,
Yes,
so we
thanks.
count as okay, we have 1 up and 1 down, 1 up and 1 down, 1 up and 1 down, 1 up and 1 down. Okay, a total of okay, 10 ups and downs. Okay, but that's just easy to go in. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, but you can see that's what I mean. It's okay. Each peak has its own trough. Did you get that, dear?
Yes, thank you.
No problem, dear. Okay. So what do we have here? A total of 10 cycles per second. Now, guys, all dependent upon it's okay what you're counting. Yeah, okay, okay. You can say it's okay, 10 breaks per hour. Clear, okay. If I give you it's okay in a span of 1 hour class, if I give you it's okay, 10 breaks. Clear, okay. Also, and so then you guys go and say it's okay, the frequency of breaks is 10 breaks per hour. Yeah, okay. Or something like that. Okay. Okay. So that'll be as okay, the frequency of any specific event in a specific duration. Clear? Okay. But when we talk about the frequency of sound. Clear? Okay. Okay. If you can say it's okay, number of cycles per second, that's okay. That's how it is counted. Okay. Now you can say it's okay. This 10 cycles per second here. That was what we had. That means it's okay going to become a frequency. We will say it's okay. Well, okay, the number is still 10. But it's okay. These 10 cycles per second here is going to be defined as, or it's going to be converted into what we will call a hertz. So in this case, our frequency was 10 hertz, which mainly means that within a time span of 1 second, we had 10 cycles completed. Did you guys get that?
Yeah.
Good. Any questions? So our actual unit in which we are going to express the frequency is going to be hertz. But what did that hertz count for? Cycles in a second. Did you guys get that? Clear? Okay. So this cycles per second. So is going to equal to what we will call hertz. Okay. And please, guys, the symbol for hertz is Hz. That's the universal symbol for hertz. H as in happy, Z as in zebra. Did you guys get that?
Yep.
Good. Now, just in this instance, where we had, as 10 cycles per second, we had a frequency of 10 hertz. Yeah. Now, please keep in mind, guys, these 10 hertz here could also be equal to, just 1 deca hertz. Yeah, okay. This 10 hertz could also be written as, it's probably not going to be, but you can still say 10 multiplied by, or 1 multiplied by 10. Well, okay. Whether you write the 1 or not, it doesn't really matter, but it's hertz. Yeah. Okay. But let's just say that, yes, within 1 second. It just says, was a span of 1 second. And if, for instance, had a total of, let's say, 100 cycles. Then your frequency was going to be 100 hertz. Clear? Okay. If in 1 second, Okay, and this 100 hertz could actually also be written as 1 multiplied by 10 raised to the power 2 hertz. Or if you don't want to raise, as I say, you want to raise to the 10 raised to the power 2, well, okay, it's a hectohertz. Now, you're probably not going to hear things such as hectohertz and decahertz, but more likely it's okay in the thousands. So it's okay if in 1 second we had a total of, let's say it's okay, 1,000 cycles. Do you guys mind if I go to another slide and make it a little clearer here?
No.
No.
Okay, good, thank you. So let's just say that, okay, yes. This, yes, okay, was 1 second, right, okay. And in this 1 second here, so okay, we had a total of 1,000 cycles. Now, I'm not going to be sitting here as, okay, drawing 1,000 cycles, but you guys get the point, right?
Yep.
Good. That would mainly mean that, okay, yes, in this 1 second here is okay. If we have is okay 1,000 cycles per second. Okay, then okay, this is going to be as okay our frequency, right? Okay. It says okay 1,000 cycles per second, or this could also be written as 1 multiplied by 10 raised to the power 3. Okay. Well, it says okay, this one is 1. This 10 raised to the power 3 here is okay, the thousands. Actually, is going to be written like this. And then we have the cycles. It's okay per second. Or it could also be written as, okay, yes, the same numbers, but it's okay, the cycles per seconds could actually, it's okay, just be, sorry, translated into, it's okay, what you call hertz. Okay, yeah, we can even go and say, yes, okay, 1. Now this 10 raised to the power 10, which was, or 10 raised to the power 3, sorry, which was your 1,000, can become, yes, okay, what you call a kilo. Because we know that a kilo was 1,000 hertz. So 1,000 cycles per second is going to mean that you have a frequency of what we refer to as 1 kilohertz. But that 1 kilohertz can be written like this. It can be as okay written like, let's say this with this. Or you can just go as okay, plain 1 K for the 1,000, add Z for the hertz. Did you guys get that?
Yes.
But. In ultrasound, we may not even talk in kilos. We actually, that's okay, are going to go into megas. So if I instance, okay, if I made as okay 1 million cycles completed in 1 second, if we had a frequency of, or we had as okay 1 million cycles completed in 1 second, we will mainly say that okay, as our frequency in that case, as what is going to be as okay 1 megahertz. Or we could even write that frequency as, well, okay, 1 is still 1. We can say, okay, that mega. Now that can be written as 10 raised to the power 6. And okay, yes, your hertz. Your hertz is at Z. You're more than welcome to write it as, okay, yes, with 1, followed by 6 zeros. and then your hertz. Did that make sense? Did you guys get that?
Yes.
Well, okay. So more likely as okay in ultrasound, what we will see is that okay, yes, your frequencies are going to be in megahertz. Okay, where you mainly have okay a certain million cycles completed in 1 second. Any questions so far? Yes, guys.
No.
Okay, so it's not 10 cycles, it's not 100 cycles, it's not 1,000 cycles, it's actually going to be as okay megacycle. Millions of cycles completed in a second when we talk ultrasound. But just so you guys, yes, okay, are on top of it's okay, your units and conversions, you can say it's okay, this frequency of 1 megahertz, right? Yes, okay, can be as okay 1,000 kilohertz. Yeah, okay, so 1,000 kilohertz is actually going to just okay make up 1 megahertz. Now it's not really rocket science. Well, okay, because okay, it says okay, this is okay was 10 raised to the power 3. Your 1 here is 1, and okay, yes, this 1,000 here is going to be as okay another 10 raised to the power 3. But maybe yes, okay, it just ends up as okay, yes, 1 is 1. Well, okay, yes, your 10 raised to the power. We can say okay, 10 raised to the power 3. And where you mean is okay as we did the other day. In this case, it's okay, just we'll add these up. But okay, the total becomes 10 raised to the power 6. So 1,000 kilohertz makes a megahertz. 1,000 megahertz makes a gigahertz. Any question, guys? Okay. So for now, yes, okay, the bottom line mainly is, well, okay, the number of cycles of sound waves completed in a second, that is going to be the frequency of that sound wave. Clear? Okay. Okay. That cycles, well, that's okay. That cycles per second is going to be translated into hertz. Okay. But if you have, yes, okay, 100 cycles per second, you can say, okay, it's going to be decahertz. 1,000 cycles per second, or the number of cycles per second that you have is in thousands, then you guess, okay, you can express it as kilohertz. Whereas if you go to the millions, it's going to be megahertz. So you go to the billions, it's going to be gigahertz. Did that make sense? Right, okay, okay. But 1,000 gigahertz, yes, okay, sorry. 1,000 kilohertz makes how many gigahertz? 1,000 kilohertz makes how many gigahertz? You want me to write it down?
1,000.
What did you say, Kristen?
1,000.
1,000 or 1,000?
Thousands.
1,000. 1/1,000, right? 1 kilohertz, that's okay. 1,000 kilohertz would make 1 gigahertz or megahertz, but 1,000 of a gigahertz. Okay, guys, the typical value of ultrasound. The typical value of ultrasound. And that's going to be, yes, okay, 2 megahertz. 2 15 megahertz. Did you guys get that?
Yeah.
Now, what do you mean by 2 megahertz is that there's going to be, yes, okay, 2 million cycles per second completed. Now, this is the lowest range because, okay, it can go up to, yes, okay, 15 megahertz would mean to me that there's going to be, yes, okay, up to, yes, okay, 15 million cycles per second. Okay, please keep in mind, guys, that, okay, yes, this 2 million, this 2 megahertz can also be written as 2 raised to the power 10, or 10, 2 times 10 raised to the power 6 hertz. Now, you may guess says, okay, that 2 is 2. The mega or the million is 10 raised to the power 6. And we can say, okay, the cycles per second is the hertz, which is hertz. Did you guys get that?
Yep.
Yeah.
Okay. Whereas, okay, guys, on the other hand, we can go and say, well, okay, yes, 15 is 15. Yeah, okay. Your mega or your million can be as okay, the same as okay, 10 raised to the power 6. And okay, yes, what we say is okay, cycles per second is going to be hertz, which is going to be hertz. Did you guys get that?
Yes.
Good. Now, guys, what's going to determine the frequency?
The sound source?
Now, just look at it this way. Earlier, when I spoke, I said this way, let's consider that, okay, each word that I utter was a cycle. And if I took 1 second to speak each word, that's okay. The period for each word to be spoken was 1 second. And that mainly mean that, okay, as the number of words spoken in a second would be 1. So the frequency of words spoken per second would be 1. Because the time that I took to speak one word was 1. Clear? Okay. And that is after, yes, okay, you guys went and say, yes, okay, we can't understand what Michael is saying because, yes, okay, he is speaking too fast. He ended up speaking and saying, yes, okay, 10 words in a second. We need to write word notes here as well. Right, okay. Okay. I'll be able to just, okay, follow around what he is saying. So that's okay. I've been requested to, yes, okay, speak slower. Clear? Okay, but if I was speaking 10 words in a second, okay, that would mean, yes, okay, the way that I was programmed to do. Yes, okay. The frequency of words spoken per second in that case would have been 10 words. And okay, the time taken to speak one word was going to be 1/10 of a second. That was too fast. Clear? Okay. But again, yes, okay, it was me as a source who would determine, yes, okay, how much time I will take to, yes, okay, speak a word. And mainly, yes, okay, due to that, that's just okay, how, yes, okay, the number of words spoken in a fixed period of time will be determined. Did you guys get that? So what did that tell you now? That there's going to be a relationship between period and frequency. Because the more words I spoke per second, well, okay, the higher will be the frequency of words spoken in a second, right? But where you mean you'll say, well, okay, yes, the time that mics take to speak each word is too high for us to catch or to understand. Whereas if, okay, as I reduce, or if I extend the time to speak each word, well, okay, yes, the period will extend, but then the frequency is also going to reduce. But all determined upon is, okay, how rapidly or slowly I was speaking. Me as being, is okay, the source, or in this case, is okay, the transducer. Okay, so we just get into, yes, okay, that relationship in a second. Now, guys, when they talk about being adjustable, I know that your book says no, right? Your book says no, right? Or if you read it, it says it's pretty much the same as what it said for period. Okay, here they just have changed the word out, the word period out of it, frequency. But that's not correct. Okay, so write it this way, guys. Yes, for updated transducers, we are able to, yes, okay, adjust the frequency. Okay, now what the, just a sec, Teresa. Okay, because in chapter number 8, where we're going to just, okay, talk specifically about transducers. Well, okay, yes, at that point, yes, okay, yes, okay, correct, yes, okay, brought up. So you can just write, yes, okay, broadband transducers. So all transducers that we have nowadays are going to be broadband transducers. Especially, yes, okay, the ones that we use for diagnostic imaging. What's diagnostic imaging? That you create an image that will help you with reaching a diagnosis. Okay, so broadband or broadband transducers. That's okay. We are able to adjust the frequency. Did you guys get that?
It's not updated ultrasound systems, it's updated transducers, like the machine
Transducers.
itself?
Yeah.
Okay.
Now, there are going to be some systems where you may not be able to adjust the frequency. But my dear, the point is that, okay, when you say adjustable, that's mainly going to be that, okay, as there will be a function. Okay. Now, on your system, and that's why it's okay, this thing should be taught online. But anyways, but when you go to your system, well, okay, what do you have? That means it's okay, 2 ways by which it's okay, you can play around with the system and make it, you can say it's okay, work in your favor. Or according to it's okay, what you want to achieve. There are knobs that you may, it's okay, twist and turn around. Just like, okay, yes, on your thermostat. Or let's say it's your microwave or stove. Okay, you have a knob that's okay, if you want to, okay, increase the temperature, it's okay, you twist and turn the knob accordingly, right? Clear? Or touch functions. Okay, so yes, okay, out of yes, okay, the 2 screens that you may see on an ultrasound system, there's going to be one of those which is going to be a touch screen. There it is, okay, you can go in and okay, just like you see in science fiction movies. Okay, science fiction movies, okay, all of a sudden, yes, okay, a screen appears, and they go in like that. Okay, but that's okay. Your systems have yes, okay, touch screen. Okay, on which yes, okay, you will be able to yes, okay, adjust certain functions. So that's pretty much okay. Yes, what it means to be adjustable. Clear? Okay, then you can go in and change around with the things. Okay, but as far as okay, the frequency is concerned, yes, okay, it is going to yes, okay, be within that typical range. Did you guys get that? So the typical range for yes, okay, ultrasound diagnostic imaging transducers is going to be yes, okay, 2 megahertz to 15 megahertz. Clear? Okay. Now some of you will say, why not 30? Or why not 25 megahertz or so and so? And okay, what you guys will see at a later instance that is okay, my more is going to be reinforced. Good is good, but not too much good is bad. Clear? Okay, well, okay, you can make a transducer with, okay, let's say it's okay, 200 megahertz frequency. Will you be able to use it for diagnostic imaging? No. And why? Well, okay, yes, we'll get to that. Okay, so that's the main, yes, okay, the typical range that they have said, okay, this is just good enough for diagnostic imaging. Any questions? Okay. Okay, let me just ask you guys to. Okay. Okay, guys, yes, we can do it this way. So the question is that, okay, why do we call ultrasound? Ultrasound. No idea? It's okay. It's okay to say no, we don't know. We've just been hearing, yes, okay, this term has been used over and over and over and over again, and we just go with the flow. Okay, then let me tell you why. Can you guys hear me? Good. You know why you're able to hear me? Well, okay, first of all, yes, okay, yes, yes, okay, I produce the sound, right? Of course, okay, if I don't say anything, yes, okay, then you won't be able to hear me. But we can mainly say, okay, the sound that I produce mainly is, okay, falls within a range of frequency that goes from 20 hertz to 20 kilohertz. So what this 20 hertz to 20 kilohertz is, okay, that's actually, it's okay, frequency of sound, right? What do you mean by 20 hertz? That, okay, yes, 20 cycles per second. What do you mean by 20 kilohertz? 20,000 cycles per second. And this is actually, it's okay, what we can say is, okay, the audible range for the human ear. Did you guys get that? Okay, guys?
Yep.
As long as a sound has a frequency that falls within the range of 20 cycles to 20,000 cycles per second, the human ear should be able to hear that. Did you guys get that? Okay. If you need hearing aid, that means that, okay, yes, the ability of your ears to just, okay, pick up sounds is declining. Yeah, okay. But that's okay, guys. Are there going to be sounds which are going to be less than 20 hertz per second? Or 20 hertz? Or 20 cycles per second? Of course there are. Okay. The fart of an ant, for instance. Okay. Okay. Well, what do we call, yes, okay, sounds that are, we can say, yes, okay, less than 20 hertz. You can go, yes, okay, 19, 20, 19, 18, da, 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 da. These are going to be considered as infrasonic. Did you guys get that?
Is that INFRA?
Exactly.
Infra? Okay, thank you.
Infrasonic, right? Okay. Yeah. Whereas up here, all this, okay, we may not have the room, But we can mean it says, okay, anything that is greater than 20 kilohertz. So anything that's going to be greater than 20 kilohertz is going to be, okay, called ultrasonic.
Mike, in the blue, that says audible rise?
Range to the human ear.
Range. Okay, thank you.
The minimum is 20, the maximum is 20 kilohertz or 20,000 hertz, right?
Yeah.
Okay. Okay. This 20 kilohertz, my dear, yes, okay. We can say, okay, the 20 is still 20. Okay. The K is 1,000. And okay, yes, the hertz is still hertz. So 20,000 hertz. Right, okay, where you could write it like this. Yes, okay, you're 20. And then yes, okay, the 3 zeros for the 1,000, and then yes, okay, your hertz. Or you could write it as 20. Your kilo was 10 raised to the power 3, and okay, yes, the hertz was hertz. But if you don't want to write it as, okay, as a 2-digit number, that's okay. You can just write, okay, as 2. Then yes, okay, you have your, okay, 10 raised to the power 3. I mean, you just, okay, yes, add 1 and get 4. So it becomes, okay, 2 multiplied by 10 raised to the power 4 hertz. That would be 20,000 hertz. But guys, anything greater, oops, sorry guys. Anything greater than 20,000 hertz or 20 kilohertz is going to be ultrasonic. Clear? Okay, so yes, okay, of course, 2 megahertz is greater than 20,000 hertz. Not to talk about, it's okay, 15 megahertz. It's also, it's okay, greater than 20,000 hertz. But this range of, okay, is between 2 megahertz to 15 megahertz is made as, okay, that's what we use for ultrasonic imaging. What about, as okay, 200 kilohertz? 200 kilohertz is still ultrasonic, but it's not going to be as okay used for ultrasound imaging. Did that make sense? Okay. Is this sound here audible? No, it's not audible to, yes, okay, to the human ear. Is the infrasonic sound audible? No. At least not to the human ear. Okay. Or 4-leg fellows. That's okay, they may still be able to hear these sounds here. Of course, that's okay, they will also, yes, okay, be able to hear, yes, okay, the regular audible sounds to the human ear. They're just going to sense it more louder. And they may even, yes, okay, be able to hear these sounds here, which are going to be, yes, okay, like atomic explosions. Or sound like atomic explosions. Okay. But maybe it's okay to catch those low frequency sounds that the human ears can't hear. That's why it's okay people used to keep dogs to watch out. They may not see, but they can hear something that you can't hear. And then what do they do then? They start barking. And that's how they will alert you. Okay. So why do we call ultrasound ultrasound? Because it falls in just okay, it's a sound which has a frequency which is about the human audible range. All that's okay. That was 20 kilohertz. Okay. Anything about 20 kilohertz is an ultrasound. But it's only going to be okay from 2 to 15 megahertz that we can use for ultrasonic diagnostic imaging. Any questions? Okay, guys. That could be ultrasonic or infrasonic, right? Okay. Okay, guys. Now, relationship. So, guys, what we can say is that period and frequency are related. How is their relationship, or what kind of relationship do they have? Well, first and foremost, yes, okay. Inversely related. What did it mean to be inversely related? That, okay, as if the period, for instance, okay, goes down, the frequency will increase. Or if you go the other way around, and yes, okay, if you increase the period, then the frequency will go down. Okay, but let's just go back to just okay, 2 or 1 second. So this was 1 second. Yep, okay. Let's just say that, okay, as in this 1 second here, okay. So, in this 1 second here, so okay, we had a total of 10 cycles. Did you guys get that?
Yep.
Yes.
Good. Okay. So our frequency in this case is going to be as okay. We can say okay, 10 cycles per second. Or more correctly, is okay, just 10 hertz. Did that make sense? Now comes the
Yeah.
question, yes, okay, what's going to be the period? For each cycle. If we had 10 cycles completed within a second. Now the period for each cycle is going to be, yes, okay, 1/10 of a second. Because we said, okay, each cycle, yes, okay, is going to, yes, okay, all yes, okay, evenly, yes, okay, divide this 1 second here. I'm going to say it's okay. 1/10 of this second here is okay, it should be completed. Did you guys get that?
Yeah.
Now, when you look at these two numbers here, what did that tell you? It made us, okay, just confirms that, okay, yes, not only is the period and frequency inversely related, but they're also going to be as okay, reciprocal. Because you can say, okay, this 10, which was the number of cycles per second, is multiplied by 1/10, which was the period for each second, or for each cycle. And what do you get? 1. So if you say that, okay, as the period, oh, sorry, if the frequency was 10 cycles per second, which means to me that we had a frequency of 10 hertz, it would take each cycle 1/10 of a second to complete. Did you guys get that?
Yeah.
Good. Let us just, yes, okay, let's say it's okay, increase the period. Or let's say it's okay, let's go and okay, let's increase the frequency. Let's say that, okay, it's in this second here. Now, I'm not going to be sitting here as, okay, drawing 1,000 cycles and 1,000,000 cycles. But we can mean it says, okay, if we had a total of 1,000 cycles per second. Clear? Okay. We increase the period, yes, okay, we increase the frequency from 1 cycle per second, or 10 cycles per second, to 1,000 cycles per second. As a matter of fact, we can say, okay, that we increase it by 100 times, right? Ten times 100 is 1,000, right? Right?
Yeah.
Yep.
Yes.
Good. So what's going to be as okay, our new frequency? Our new frequency is going to be as okay. Okay, guys, do you mind if I go to another slide?
No.
Nope.
We can always get back to this one here for verification. Okay. So what do we have now? Yes, okay, we have a frequency of 1,000 cycles per second. What can we call this frequency here? Yes, okay. This frequency can also be 1000. This cycles per second here can also okay be 1 hertz or hertz. Or we can actually say that the frequency, this frequency could also be as okay written as 1. The 1000 here is okay, could be kilo. And okay, as your hertz, could be hertz. Or 1. Now multiply by 10 raised to the power 3. Hertz. Yeah, okay. But what we mainly said that we had, in this 1 second here, was now is okay a total of 1000 cycles. Which mainly as okay just brings us on to as okay, the question is what's going to be the period? Now, if you are going to be able to just okay fit 1000 cycles or complete 1000 cycles in 1 second, what did we say that period was? It was going to be the time that it takes 1 cycle to complete, right? That's going to be 1 over 1000 of a second. Yeah. So this 1 over 1000 of a second can also, be written as, if you say, okay, that period, it's okay, it could be written like this. It could also be written as, okay, as 1 multiplied by 10 raised to the power minus 3. Clear? You can even write it, okay, as a decimal as 0.001 second. Or you can even say as, okay, let's do it this way and say as, okay, 1 is still 1. This 10 raised to the power minus 3 is a milli. And second is a second. Did you guys get that?
Yes.
Okay. But you can still say as, okay, if you multiply this by this, what do you get? You get 1. Or we can say it's okay because it's okay, our frequency here is okay, was 1000 hertz, which means 1000 cycles per second. That may mean that okay, as each cycle is going to be completed in 1000 of a second, which can be written as a decimal form like this, or it's okay with this exponent form of this. Clear? Okay. But what did that tell us? That the increase of the cycles per second is going to have an opposite and equal decrease in the period or the time that it takes each cycle to complete. Clear, okay. And why that increase on one side is equal and opposite to the decrease in the other side makes two parameters here reciprocal. You can go on to the next example and see, as okay, what about if we had 1 million cycles completed in a second? Then the time that it takes a cycle to complete is going to be 1 millionth of a second, right? Your frequency was going to be 1 megahertz. The period was going to be a microsecond. Did that make sense? If you go into gigahertz, that says, okay, 1 billion cycles completed in a second. That was going to be, as okay, 1 billion cycles, that's going to be 1 gigahertz. Did that make sense? Okay, but then yes, okay, the period of each second or each cycle was going to be as okay, 1 billionth of a second, which is going to be 1 nanosecond. So the first day of class, when I told you that nano is reciprocal to giga, micro is reciprocal to mega, milli is reciprocal to kilo, centi is reciprocal to hecto, and deca is reciprocal to deci. You see where that comes in? Okay. Because it says, okay, if I have a frequency, it's okay expressed in kilohertz. The period can be as okay in millihertz or milliseconds. Okay, you can for instance, okay, have 200 kilohertz. Now the thing here is going to be as okay, that's going to be the number of, or the period is going to be reciprocal to 2, which is going to be 1/2 thousandths of a second. Did that make any sense at all? So let me see. Yeah, okay. So maybe that's okay. This number here, yes, okay, is reciprocal to this. Mainly because, okay, we say it's okay. Hertz, but here we said seconds. So guys, if I say that, okay, as we have a frequency of 20 megahertz, and ask you, yes, okay, what's going to be the period? Let me just say, yes, okay, just to simplify it, okay, yes, in seconds. Yes, guys, we have a frequency of 20 megahertz. What is going to be, yes, okay, the period?
Should be 1/20 million second.
Exactly, Kristen. Do you mind tell the girls how you got that?
It's just the reciprocal of 20 million. 20 megahertz would be 20 million.
Okay, you're gonna say it's okay for this way. The reciprocal of 20 is watt over 20, right? The reciprocal of milli or mega was milli. And say it's okay per second, it's okay here, hertz. Okay, or if you want to go this way and say, okay, how can we write this? Well, okay, yes, U20 will be 20. The mega is okay as 10 raised to the power 6. And it's okay, this is just your unit. Now there's 1/20 here. Okay, that's going to be because it's reciprocal. But you can still say it's okay, it's going to be 20. Now here's okay, is the milli, which will just be this. And then it's okay, seconds. Now, Kristen, you don't say anything. Let some of the girls answer. So if we have a for instance, okay, let's put it this way. We have a period of 4 milliseconds. What is the frequency? In hertz.
One fourth.
Fourth what?
1/4 hertz.
No.
1/4 megahertz.
Oh, we can do this way. 1/4 of a megahertz. Okay. Well, it's going to be weird to say it's okay, 1/4 of a megahertz. So 1/4 is going to be as okay. 0.25. Not a mega, my dear. Kilo. Kilo and milli are reciprocal. So the quarter of 1,000 is going to be 2,500. But you still say that, okay, at this or this or this will multiply to become 1. That's okay. Chew on these. Okay. Now, if you go and say, it's okay, 15 megahertz, that was the upper number, right? So what are you going to have? 1/15 of a microsecond will be the period, right? Or 1/15 of a microsecond will be the period. Okay, guys. The relationship between any period or anything measured in time, which will be periods of different types, and frequencies of different types are always going to be inversely proportional and are always going to be reciprocal. So when you say that they are reciprocal, yes, okay, you directly said a cover up for being, yes, okay, inversely proportional. Clear? Okay. Now, when I said that, okay, yes, being inversely proportional just means that, okay, when one increases, the other one decreases. Clear? Like this. Okay. But as okay, when you go reciprocal, there's no doubt about it that, okay, as one will increase, the other one will decrease. But then you go more specific and says, okay, the times that this increase, there's going to be an equal but opposite decrease on the other side. So being, yes, okay, reciprocal automatically clears out that it is inversely proportional. Clear? Okay. By one thing, yes, okay, increases, that's okay. 1,000 times, the other is going to reduce to 1,000. That's why I say kilos and millis were reciprocal. Clear? Okay. What makes period and frequency reciprocal is that, okay, as the shorter the period, the greater the frequency. Clear? Okay. 1,000 cycles in 1 second is going to call that, okay, the time for each cycle is going to be the 1,000th of a second. 5,000 cycles in a second, for instance, is going to mean that, okay, yes, each cycle is going to only be as okay, are going to as okay be completed in 1/5,000th of a second. 10,000 cycles in a second. Each cycle only can, or each cycle is going to take 1/10,000th of a second to complete. Did you get that? So in that sense, that's okay. That's what we say that they are reciprocal. But even yes, okay, if you look at the unit frequency, what did we make it up of? And especially here as a question. Okay, why are you doing this to me also? If you look at frequency, what did we say? Okay, it's going to be equal to, yes, okay, the number of cycles. Per second. Frequency, well, okay, yes, this was going to be, yes, okay, the unit R because it's okay. This whole thing here would be equal to, yes, okay, what we can call hertz. But what do you see here? Unit of period. As okay as the denominator. And what did that mean? That the denominator of this thing is okay. As a denominator is always going to be as okay, inversely proportional to this fellow here. Where you can see it's okay. That number of cycles is the numerator. Is going to be as okay directly proportional to your frequency. Did that make any sense? So we said, okay, as that frequency was the number of cycles, that becomes the numerator, right? You increase that. That's going to increase the frequency. So those number of cycles was directly proportional to the frequency. If you kept the unit of time constant. Well, that's okay. In accordance to the equation, what did you see? That the denominator was a unit of time. Right, okay. Which makes it inversely proportional to what we calculated here, which was the frequency. So just as okay, a little awkward way of okay, yes, remembering it. But just put it this way, yes, okay, if I was speaking, yes, okay, 10 words in a second, it would take me 1/10 of a second to say each word, right? Because in a span of 1 second, yes, okay, I have to say 10 words. If I only speak 5 words in a second, well, okay, the frequency of words spoken in a second was going to be 5. So actually, it's okay, half the frequency. But instead of having, yes, okay, 1/5 or 1/10 of a second to, yes, okay, speak each word, which are going to be the period, now it's going to be, yes, okay, 1/5. So the period doubled, whereas the frequency halved. So that's why you can say, okay, that period and frequency is or are reciprocals of one another, which directly as okay covers that they are inversely proportional as well. Any questions? So what's going to be the period of a cycle for a 2 kilohertz frequency? 2 kilohertz frequency, what's going to be the period of the cycle? Two kilohertz.
Is it a half?
Half what?
Is it millihertz?
2 kilohertz. Okay, half what? What's the reciprocal of kilo?
Millihertz?
Wouldn't it be milliseconds?
Millisecond, half a millisecond, right? Did that make sense? Good. So while chewing on your food, that's okay. How frequently says okay, what should be the frequency of times you chew on each bite? Or how many bites should you how many times should you chew on each bite?
Isn't it like 20? 20 bites? Or
20 bites? Well, okay. You're only
22.
allowed to take 20 bites. Would that fill you up, my dear?
No, 20 chews per bite. That's what
20 chews per bite. Okay, good. Okay. Yeah, okay. And then you says, okay, how many times are you able to chew in a second? And that will mean that's okay, tell you that's okay, then when you go with that, you can say, it's okay, how many bites are you going to be able to take in 10 seconds, 5 seconds, 18 seconds, whatsoever. Okay, you can go chew like that, or you can go in like that. Yeah. Or you can chew so fast that people think you just go, oh, oh, oh. Okay. Okay. But chew on this, but please don't get choked. Okay, please don't get choked while you just okay, try to swallow your food. And when we come back, yes, okay, we can see if you guys still are. It's okay, lost on that. I want to talk more about it, okay? Oh, let me see. Why? Oh, do you see what I see? No, it's not written on the roof, Caitlin. Do you guys see what I see? No? What I see is that there's, okay, yes, a total of 10 nice questions about period and frequency. So why do you guys do those as well? And I see you guys at 12, not 12, sorry. That's going to be, that's okay. I see you guys at 1/5. Teresa is just like, okay, making a face. Is he going to say 50? Okay, let's say 115. Okay, guys? Okay, have fun. Okay, guys, so where are we? Here's our board. Good, so what do we have? Question number 1. Okay, now what is the period of the Earth's rotation around the sun? So this was the sun. And this is the Earth. This rotation here is around the sun is going to be equal to 1 year. Clear? Okay. Whereas if we said, okay, this was the Earth, and we say that this is the Earth's axis, then yes, okay, one rotation around that axis is going to be 1 day. Did you guys get that? Anyways, but okay. Question number 2. A little dumb question, but anyways. Okay, look. A spinning top is spinning on the table. What is the period of the spinning top? Okay. And the reason that, okay, I said 0.05 seconds. It's only because this is the only one that, okay, uses just, okay, the unit of time. Clear? Okay. So that's the only one. That's the reason. Okay. You may be spinning as, okay, a spinning top on, okay, as any surface. And, okay, it may spin faster than that. Clear? Okay. Well, that's okay. By 0.05 seconds, that will mean that, okay, it spins 40 times per second. No, not 40 times, sorry. 20 times in a second. Clear? Okay. So that's going to be as, okay, the frequency of the star spinning around 20 times in 1 second. Now, which of the following waves are infrasonic? Now, when we said infrasonic, you mean it says, okay, yes, okay, a frequency below the human audibility. Yeah, okay, so anything that's going to be as, okay, we can say as, okay, less than 20 hertz. Clear? Okay, so 20 mega or 4 megahertz, that's greater than 20 hertz. 400 kilohertz is also greater than 20 hertz. Okay, 28 hertz is also greater than 20 hertz. Everybody should agree that 20 is, or 28 is a number that's greater than 28. So the only one that's less than 20 is 2 hertz. Is that clear? Did you guys get that?
Yep.
Good. Now, just a dumb question. But that 400 kilohertz, what would that be in megahertz? Your 400 kilohertz, what would that be if you use the unit megahertz and not kilohertz? Okay, go ahead, my dear. You good? You good, dear? Teresa, you good? Yes, guys. Anybody?
Don't yell at me.
Point
But
four.
Okay, Kristen, let Caitlin answer. Let's see what she has to offer.
Yeah, sorry about that.
Is it 400,000?
Well,
Well,
okay,
it's not 4 million, is it?
my dear, my question is straightforward. You had 400 kilohertz, right?
Yeah.
Good. My question is, how many megahertz is that going to be?
Is it 0.4?
Who was that?
Lily?
Exactly, my dear. 0.4 megahertz. Look at it in this way, guys. This was 100, right? 100 is 10 raised to the power 2, right? This is kilo, which is 10 raised to the power 3. Yeah. When we add these two together, it becomes 10 raised to the power 5. What was your mega? 10 raised to the power 6. Yeah. So you even out, that's okay at that point. So it's going to, that's okay, 1/10 of a megahertz. There you go with, which becomes as okay a 1 decimal number. So 0.4 megahertz will be the answer. For us, okay, 4,000 kilohertz. Oh, 400 kilohertz, sorry. Yeah, okay. Had it, for instance, been 4,000 kilohertz, then if you express that in megahertz, then that would have been 4 megahertz. Because, okay, here, this was a 10 raised to the power 3. This was a 10 raised to the power 3. And when you add those up, it comes 10 raised to the power 6. We then would just have been 4 megahertz. But good job, Leland.
Thank you.
Okay. Katie, did you get it, my dear?
Yeah.
Okay. Okay, guys. Now the next question, question 4. Mainly it's okay. It's pretty much okay. No, not exactly. But what the mainly is okay, just asking is okay, which of these is ultrasonic? And what would it mean to be ultrasonic? Yes, okay, have a frequency that was greater than 20 kilohertz. Clear? Okay. Now don't go by the numbers because you also have to just okay look at your units. Now the first one is a tricky one because it says okay 400. But please guys, it is a lowercase m. So this lowercase m here is okay, that is actually it's okay going to be a milli, which means yes, okay, or mean 1000. And then you go hertz. So 400 millihertz actually is going to be as okay, you can say 400 divided by 1000 hertz, which actually ends up as 0.4 hertz. Why? This 0 cuts this 0. This 0 cuts this 0. And now you have are left with, okay, yes, 4 divided by 10, which becomes 0.4. Yeah, okay, so forget about 20, forget about 2 hertz. You have, okay, as the fraction of hertz, which under no circumstances can be ultrasonic. Clear? Okay, you go 4 megahertz. Well, okay, yes. 4, although yes, okay, 4 is a number that is smaller than 20. But then you go with the unit which is greater. This is a greater unit than kilo, right? Kilo was just 1000. This mega is a million. Did you guys get that? Clear? Okay. Likewise, that's okay. Now 28. Well, okay, it's a number that's greater than 20, but that's okay. The unit that you have is just hertz. Anything that was going to, yes, okay, for it to be ultrasonic had to be, yes, okay, greater than 20 kilohertz or 20,000 hertz. Clear? Okay, so only it would only have been ultrasonic had it says okay 20,000 hertz or 28,000 hertz, which means it required okay you would have had 3 zeros. Okay, we actually that's okay correct. Also means okay 28 kilohertz because the 3 zeros is 1,000, which becomes a kilo. Did you guys get that? Did you guys get that?
Yes.
Any questions? No questions? I guess not. Okay, now here to go more specifically to it and say is okay. Now which of these let's say okay. Now which of these waves are okay, which of these waves is ultrasonic. So what are we looking for? That's okay, because that's okay, a frequency. That's okay, a frequency that is greater than 20 kilohertz. Okay, and useful in diagnostic sonography. Okay, so useful in diagnostic sonography. And what would that be? That the range is between 2 megahertz to 15 megahertz. Clear? Okay. Now what we see here is that, okay, option A is 400 megahertz. Okay. There's no doubt about it that, okay, yes, it is greater than 20 kilohertz. So it's okay, it falls under yes, okay, being ultrasonic. Clear? Okay. But it is far, far, far beyond the normal range of ultrasonic diagnostic sonography. Did that make sense? Okay, so had we not had this thing here is okay in the question, then okay, as this could have been a correct answer. For me, it's okay, the child answers even more by saying it's okay and useful in diagnostic imaging. So it has to fall within this range here. Did you guys get that?
Yep.
Good. Now the next option is mainly as okay, just 4 megahertz. So that of course that's okay, that's greater than 20 kilohertz. Clear? Okay, and it falls in between, yes, okay, 2 megahertz and 450 megahertz. If you start counting from 2, yes, okay, you go 2, 3, 4, boom. Okay, but not just the number, guys, also, yes, okay, the units are the same, right? Okay. Did you guys get that? Okay, but please keep in mind, guys, okay, yes, these 4 megahertz, yes, okay, could also be 4,000 kilohertz. Did you guys get that? Or they could be as okay, so mean that write it like this. Which become just okay 4 million hertz, which is 4 megahertz. Yeah, okay. Now option number 3 is just 2 kilohertz, which plainly as okay is just going to be as okay simply 2,000 hertz, which is less than 20,000 or less than 20 kilohertz. So this is not meeting any of the criteria. Yeah. Now D, that's okay 2 with okay this one. That's made as okay just 200 kilohertz. Or you can say okay 200,000 hertz. Clear? Okay, and which actually that's okay would be 0.2 megahertz. So it's okay as 1/10 of the lower limit for a sound to be used in ultrasonic sonography. But yes, okay, it still fulfills the criteria of being greater than 20 kilohertz. Usually, did you guys get that?
Got it.
Okay, dear guys. Now just looking at question number 6. Now identify all the ways that are inaudible. Clear? Okay, now what do we need for a sound wave to be inaudible? It's going to be anything but 2 to 20 kilohertz. Any frequency that doesn't fall in between these two are going to be inaudible, because it's okay. It's like you said, less than, it's going to be okay infrasonic. And if you go yes, okay, greater than is going to be ultrasonic. Okay, now let's just look at the first option, 4 megahertz. And 4 megahertz, dear guys, is okay, falls here. Okay, it is greater than 20,000 or 20 kilohertz or 20,000 hertz. That's okay. This one here is going to be inaudible. Okay, we can go on to the next one. It says, okay, 400 kilohertz. Well, of course, that's okay. That's going to fall here as well. Okay, now you can say it's okay, mean it's okay. This unit here and this unit here is the same. And okay, yes, everybody should be able to say that, okay, of course, that's okay. 400 is greater than 20. Clear? Okay, but you can say it's okay in megahertz. Is okay. This file here is okay, or B is okay, or we just said earlier it's okay, 0.4 megahertz. Okay, now 28 hertz. I'm not 20. That's also. So 28 hertz. Yes, okay, dear guys. Falls in this range here. Okay, so this one here is audible. And then they go, yes, okay, 2 hertz. 2 hertz is less than 20 hertz. So that's also going to be inaudible. So A, B, and D, or A, B, D, yes, okay, were the ones which were inaudible. C, which was 28 hertz, yes, okay, falls between 20 hertz and 20,000 hertz. Did you guys get that?
Yep.
Good. Thank you. Now, which of the following wave has the longest period? So what are they asking about is okay. The longest period, okay. And okay, what they have given us is okay, yes, different frequencies. Now, what they're asking about is okay, the greatest period. So what they actually is okay, indirectly, or the cheat point here is, or what you mean is okay, just one needs to look at is or pick as the answer is going to be as okay, the one with the lowest frequency. Yeah, okay, that will be the way with the longest period. So one that we have here is, well, okay, yes, we have what is going to be 2 megahertz. We have, okay, yes, what we can say is, okay, 4,000 hertz. Okay, we can just get the unit straight and say, okay, this 4,000 hertz is going to be 4 kilohertz. Clear? Okay, then we go to the next one and say it's okay, 6 hertz. Clear? Okay, and then the next one is 1 kilohertz. Okay, where this 1 kilohertz actually is okay. Kirby is okay, 1,000 hertz as well. Clear? Okay. So the lowest number with the lowest unit is this dude here. Is that clear?
Yes.
So what would I mean? That, okay, yes, you have 6 cycles in a second. What does this mean? That you have 2 million cycles in a second. You have 4,000 cycles in a second. You have 1,000 cycles in a second. So yes, okay, this is going to be, okay, 1/6 of a second. That's going to be the longest of all the periods. But mainly because, okay, this was the lowest frequency. Did you guys get that?
Yep.
Okay. So it's not just the number, guys, but it's okay, also the units. Because, okay, you say it's okay, the smallest number, then okay, yes, this one here is the smallest number. Numerically, right? Okay. But then this here is okay, just makes it super, super big. Did you guys get that? Okay.
Yes.
So those are just okay, the small, just okay, you can say it's okay. Fixies that may be as okay in the basket. Now question number 8. Now of the 4 waves whose periods are listed below, which has the highest frequency. So we actually just okay have 4 periods. Clear? Okay, and what they are asking about is that okay, which of these 4 here is okay is going to is okay be the one with the highest frequency. That mainly mean that okay, as we need to pick the one which is the smallest period. But let's just see what we got. Because okay, we got a period of 8 seconds. Now we have okay as a period of 80. Okay, 80 is a greater number than 8. But if you look at the unit here, it's going to see as okay be microseconds. So what a microsecond is going to be, guys, that's going to be okay 1/1,000,000th of a second. Yeah, okay. The next fellow is, although it's okay, that's also just 8, similar to what we have here. But okay, then they go, yes, okay, megasecond. Now this mega here, actually, that's okay, will mean that, okay, yes, 1 million. So 80 million seconds. That's a couple of hours, not to talk about maybe even days. Clear? Okay. And then we have, okay, 800 kilo seconds. Vega says, okay, 800 is 800. The kilo here is just going to be, as okay, another 1,000. So 800,000 seconds. Okay. Now you have, yes, okay, 8 seconds, or yes, okay, 8 or yes, okay, or 80 or the millionth of a second. Is this one here. Did that make sense? That's going to be the one with the greatest frequency. Any questions? Any questions, guys?
No.
Good. Now, question number 9. Now, the following frequency, okay, of the 4 waves whose frequencies are listed below, which has the longest period? So that's okay, we got different frequencies here. Okay. What the main is, okay, are asking us is, okay, which has the greatest period. That will mainly mean that, okay, as we need to look at, okay, affect the one that has the lowest frequency. So what do we have as options? 12 kilohertz. Well, what 12 kilohertz mean, that actually means 12,000 hertz. Clear? Okay. What's the next number that we have is 6,000 hertz, directly written. Okay, but that could also have been written as 6 kilohertz, just so you have it as a reference. Clear? Okay. The next one is, okay, yes, 205 hertz. Well, let's do it here. Yeah, okay. If you want, yes, okay, express that in kilohertz, that's going to be, yes, okay, 20.5 kilohertz. No, sorry. 0.25 kilohertz. And then you have, yes, okay, 1 kilohertz, which is just 1,000 hertz. So the only thing that you got left to do is look for the smallest number, which is 205. Which will have, yes, okay, the greatest period of all these. Yeah, okay. Had they done the opposite, I says, okay, of these waves, here's okay, which has the lowest period, then you just have to pick the one with the greatest frequency, which would have been 12,000 hertz or 12 kilohertz. Did you guys get that?
Yes.
Good. Last page. So question number 10. Of the four waves whose periods are listed below, which is the lowest frequency? So we have four periods again, right? Okay. We have four periods, and what are they asking us for is, okay, which is the lowest frequency? So since they're asking about the lowest frequency, then we're just going to pick the one which is the greatest period. Now, what a number. 8 seconds. Then we go and say, okay, 8. And you see that funny sign, which is the mu, which is a micro. Clear? Okay, so that would actually just okay mean 1/1,000,000 of a second. Good. Then we have, okay, yes, 8 megaseconds, which is going to be as okay, a plane million. So actually it's okay, 8 million seconds. And then the last one is 800 kiloseconds. But it's actually going to be as okay, 800,000 seconds. But US, okay, 800,000 seconds is still less than 8 million seconds. So this one here is going to be the one with the greatest period, and hence, yes, okay, the lowest frequency. Whereas, okay, guys, sorry. Had asked us the other way around and say it's okay. Shortest period, which is going to be as okay, the greatest frequency. Or I mean this one here. Did you guys get that?
Yes.
Any questions?
No.
But guys, yes, okay, please go and okay, yes, try to just okay, me, yes, okay, talk of different, okay, practice a little bit, okay, yes, different frequencies, and try to find, okay, what the periods could be, or the other way around. Okay, do a little, that's okay, self-practice on those things. Okay. Any last words of wisdom before I adjourn the class? Okay. They say we are having a storm this Sunday. I don't know about you, Caitlin and Rhode Island. What's the weather like there? If you're having it in Connecticut, you probably is okay.
Yeah, I don't know. I haven't looked at the weather.
Okay, yeah, don't do because it's too depressing.
Okay, I won't. Thank you.
But just for you, for everyone. Okay, dear. Okay, storm or no storm, at least it's okay since we are online. We can't say, well, okay, snow day, yes, okay, or it snows, we can't make it to school, so no class. That excuse is gone. Right, okay. Those were the days. America said, okay, yes, it's more than this many inches of snow, it's okay, classes canceled. But that was a headache then, because then, okay, as you had to like, okay, get up, okay, as shut o'clock, just to make sure that, okay, as to email Caitlin that, okay, she didn't need, she is okay, start her ride close to the midnight hour, she is okay, be able to make it to school. Okay. Otherwise, she could risk it, okay, driving all the way just to come and, okay, let's look at a door that wouldn't open because classes were postponed. Okay, guys. Now, on Monday, what will we start? It's okay, what I mean, it's okay, just tend to do is, okay, make a little step of a human, great step for humanity, and jump to wavelength. So that's what we will be starting with on Monday. And once we're done with that, we go to our bigness fellows. And okay, if we get far enough, it's okay, we may be able to chalk off vacation speed. I don't think so, but let's see. Okay. Okay, guys. Enjoy your weekend. Snow or not, storm or not. Stay indoors, stay warm, chill, and read. And if you have any questions that pops, it's okay. You are more than welcome to. It's okay. Email me. Okay. Everybody got my email, right? Good. Okay, guys. Oh, guys, sorry. Have fun and enjoy. Okay.
Bye. Have a good
Have a
weekend.
good week.
God bless. God bless you.